everyone. Today we cover the second part of experimental techniques, which is separation techniques. Separation, from its name, you have things that are mixed together physically and you want to separate them. But first, let us remember the difference between element, compound, and mixture. An element is made from one type of atom. Compound is made from two or more different types of atoms chemically combined. While a mixture, they are physically mixed together, whether they are a mixture of elements like this one, mixture of compounds like this one, mixture of compounds and element like that one, but in all cases, it's a physical mixture. Also, let us remember the difference between soluble and insoluble substances. A soluble substance means, for example, you have salt and water. If you mix both and you stir, it will dissolve and disappear. An insoluble substance will remain and you will be able to see it in a heterogeneous mixture. When a substance dissolves fully, it is called a solution. And a solution is formed of a solute, which is the substance that will dissolve, for example, salt, and a solvent. Solvent is a substance with the ability to dissolve other substances. The solute dissolved in the solvent forms a solution. How do I separate a mixture? It depends fully on their properties. For example, if I have two substances, one has magnetic ability like iron and the other does not. So I can use a magnet to separate. I have a mixture of two substances. One has the ability to sublime, the other does not. So basically, you put the mixture and heat it. The substance that will sublime, meaning it will change from solid to gas directly, and I can collect it on a cool surface, leaving the other substance behind. There are other properties that we can use, like solubility. If I have a mixture of two substances, one of them is insoluble solid and the other is a liquid. For example, if I have sand and water, I separate using filtration. Filtration needs mainly two things: the funnel and the filter paper. I pour the mixture in the funnel. The liquid will pass through the filter paper and it is called a filtrate. What will remain in the filter paper is the insoluble substance, and we call that insoluble substance residue. Note, the substance is not pure because it is still wet with the liquid. How do I make it pure? After I do filtration, I wash it, and after that, I dry it between two filter papers. Okay? The second step, if I have a solution. Let us say, for example, I have salt and water. Salt is soluble in water, so I will have a solution. How do I separate? Using crystallization. So I have my solution, I heat it to evaporate it. As I heat it, how long do I leave it to heat? Like I leave it to heat till all of the water is gone? No. We say we heat to crystallization point. Crystallization point is the point where crystals will start to appear in the solution. As I see them appearing, I will stop the heating and I will leave it to cool to form crystals. So why do I need to leave it to cool? Because solubility will decrease on cooling. Again, we heat the solution to crystallization point. We leave it to cool to form crystals because solubility decreases on cooling. Now I have a mixture of crystals in a liquid. How do I separate? Filter the crystals and dry them between filter papers. Mind you, I have to dry between filter papers because if I dry in the oven, I will lose the water of crystallization. Again, while crystals are forming, the soluble substance is attached to water, which is called water of crystallization. I have to dry between filter papers or I will lose the water of crystallization. So let us say, for example, if I have a mixture of sand and salt, how do I separate? I will use these two processes. I will first add water, filter, wash, and dry the residue in order to obtain the pure sand. After that, I will take the filtrate. I will heat the filter to crystallization point, leave it to cool, filter and dry the crystals formed between two filter papers to obtain the pure dry crystals of salt or sodium chloride. In this process, we obtained the solute. We obtained the solute, the substance that dissolved, which is the sodium chloride. The solvent, which is water, it simply evaporated. But what if I want the solvent? I don't want the solute, or I want both solute and solvent. For example, I have seawater and I want to obtain water from seawater, which is called desalination of seawater. What do? I do simple distillation. Basically, I have the mixture in a flask which is closed by a stopper and connected to a condenser. What happens is that because of the difference of the boiling point, which is the concept why distillation works, there is a huge difference in boiling point between the sodium chloride and the water. What happens? Water has a lower boiling point of 100. So water will evaporate. As it evaporates, water vapor enters the condenser. As it enters the condenser, it will cool down and be condensed into water, leaving the salt behind in the flask. So I have two physical properties, which are evaporation and condensation. Number two, the process works because of the difference in the boiling point between the salt and the water. What happens as I heat the mixture? Water will evaporate, condense in the condenser, and be collected, leaving the sodium chloride or whatever solid behind in the flask. Remember, a condenser is filled from the bottom and it is emptied from the top. If I have a mixture of two miscible liquids, for example, ethanol and water, I will not be able to separate easily. So I will also use distillation, except this time we will use fractional distillation. It is the exact same concept as simple distillation, meaning difference in boiling point, meaning evaporation and condensation is the key. The difference is that I have a fractionating column. The fractionating column is basically, it's like a glass tube which is filled with glass beads or something inside. The use of the fractionating column is that it will condense the liquid with the higher boiling point. For example, I have aqueous ethanol. Aqueous ethanol is ethanol mixed in water. So I have ethanol, which has a boiling point of 78 degrees Celsius, and I have water, which has a boiling point of 100 degrees Celsius. Because ethanol has a lower boiling point, it will evaporate first. Some of the water may evaporate, granted, because evaporation happens at any temperature. But water will condense and fall back into the flask because of the fractionating column. Ethanol will pass. How am I going to be sure? I will find that the reading of the thermometer will be 78, which is the boiling point of ethanol, up until all of the ethanol is collected. After all of the ethanol is collected, the temperature of the thermometer will start to rise. Again, I have two liquids. The one with the lower boiling point will evaporate first. The thermometer will read the boiling point of that liquid, and after it passes completely, the second liquid will start to pass. If I have immiscible liquid, like they are in different densities and they don't mix, I simply use a separating funnel. You open the top, correct the first one, and after it is collected, you are left with the second one. For chromatography, it's a very specific way because it is used to separate and identify substances. Basically, I have a colored pigment, chlorophyll, for example, colored ink, whatever it may be. I will use chromatography. First, I get a chromatography paper. On the chromatography paper, from the bottom, I leave like a centi or 2 centimeter, and then I draw a line using a pencil. On this line, I put a drop of the sample that I want to test. After that, I take the chromatography paper and put it in a solvent, but I have to take care The line that I drew must be above the level of the solvent. After that, the solvent will rise, and as it rises, it will dissolve the substance or my sample and separate it as it goes up. If I have a pure substance, for example, it is formed of one substance only, then it will separate to one point only. But if it is a mixture, it will separate to more than one color. This is happening because the solvent is dissolving the mixture. And the higher the solubility, the higher that the sample is going to rise in the chromatography paper. So I draw the line in pencil because I don't want the pencil to dissolve. A pencil is insoluble. So as the solvent rises, the pencil will remain and it will not dissolve and interfere with the results. I put the line, my baseline, which is called baseline, above the level of the solvent to prevent the sample from washing out. If the level of the solvent is higher, the sample will simply dissolve in the solvent and be washed out and it will not separate. I analyze the paper as follows. It is called finished chromatogram. If a substance separates to one point, it's a pure substance. For example, A, B, C are pure substances, while M is a mixture. Number two, if you look, you find that A corresponds to one of the points in M, B corresponds to one of the points on M, C is the same thing. This means that M is a mixture of A, B, and C because it has one point that corresponds at each horizontal level to each one of them. Another way to identify, first, let us imagine I have a mixture of amino acids or sugar which are colorless. I will not be able to see them. So what do? I use a locating agent. I spray the finished chromatogram with a locating agent which is used to make colorless spots appear or colored. So I don't see anything. But when I spray a locating agent, I can see them because it reacted with them, function of which is to make colorless spots appear. Now that I see them, I need to identify them. How do I do that? By measuring the RF value. RF is short for retention factor. Basically, we measure the distance traveled by the spot from the baseline, and I divide it over distance traveled by the solvent line from the baseline as well. That's my starting point of measurement. You note that it must be less than 1 because the solvent front will rise higher. Number 2, the higher the RF value, the higher the solubility because it will mean that the distance traveled higher up the chromatography paper. And that's it for separation techniques. Next time we talk about chemical analysis. Thank you all.